All right, guys, I wanted to go through assignment 9 with you because this is a chapter that a lot of students struggle with. And a good reason, or good part of the reason why, is because there's so much details that you have to pay attention to. Okay, and so, if you didn't read the textbook, if you didn't watch all the videos or whatever, and if you just went to the textbook and tried to grab sample code, which a lot of people did, and then just tried to ram it in to your program and try to get it to work, you probably struggled, right? And I'm not talking down to anybody about that. I mean, this is how pretty much everybody starts off, right? They get the programming process backwards. Okay, you just jump in and you're like, I want to start coding, and then I'll go back and read the text as I need to. It's backwards, right? It's backwards. You have to first understand what it is that you're trying to do and what code means. Okay, and the programming process is step one, understand the problem. Step two, come up with a plan, and then step three is write the code. The writing the code is the easiest part. That's the least important part, because if you don't understand what you're trying to do, then you're not going to be able to write the code correctly, right? So you have to understand what the problem is, what you're trying to solve, so that way you can choose the right code to write a program to solve the problem. Okay, if you get that process backwards, you'll never get it right. And that was the case with so many people on this assignment. And I'm not picking on anybody. I'm not picking on anybody because everybody does that, right? I'm just trying to tell you so that way, hopefully, I can break you that habit sooner rather than later. Okay, especially when things get hard, stuff you were able to get away with in 110 without, maybe you were able to just kind of figure it out and do it in your head, and all that kind of stuff. It doesn't work after a while, okay, because it gets too complex. So what I want to do is I just want to go through the work with you and explain each one of the methods and requirements and all that jazz. Okay, so what I have is I said that you can start off with the solution from the code from the solution code from the previous assignment, right? Assignment 8, right? So um, that's what I did. Okay, I copied that and posted it here. Oops, let me bring it back as our starting point, right? So what you had to do is you had to add a bunch of methods, right? The new stuff. Okay, so what did we have to do? We had to add a copy constructor. We had to do an overloaded copy assignment operator. We had to do the stream insertion operator, a couple of relational operators. But we'll go and we'll look at the requirements as we go. Okay, so let's do that. Let me switch over. Okay, and bring up those requirements. Okay. All right. So we'll just go top down. Okay. So you need to have a copy constructor. Now the copy constructor has to be written in such a way that you end up with duplicate objects that have their own independent arrays if needed. Okay. So you can't just simply copy the contents of one numbers pointer to the other, for example, because if you did that, you could end up with both int vector objects sharing the same array, right? And the text talks about why that's bad in the sample video that I posted, why that's bad. Section 14.4, and if you scroll down, I think it's figure 14.3 and 14.4, it walks you through this, okay? So you got to make sure that you got two separate objects that are independent of each other, but contain a copy of the same data, basically. Okay, just like if you had int x and int y, and you said x equals y, they're two separate variables. They just both have the same values. That's all. Okay, so let's add our overloaded copy constructor. Okay, so and what I'll do is once this is done, I'll actually put this code up for the solution instead of what's up there now. I'll replace it. Okay, so that way, you know, when you're following along with the video, it'll mirror exactly what's, you know, what's in the video. Okay, anyway, so copy constructor, right? Same name as the class, and it's going to have a constant int vector reference as its parameter. Okay, so let's go define that. And it's a constant reference to be more efficient, and the copy constructor shouldn't be able to modify the right-hand side object. You know, the textbook talks about the left-hand side and the right-hand side. So when you have something like this, int vector ij, right? J is the right-hand side. You can also do this, right? Both of those trigger the copy constructor. So J is the right-hand side right here. So the I object has no business being able to modify the contents of the J. It's just pulling stuff from it. Okay, so let's go ahead and define, write the code for it. Let's put the logic in there. Okay, so I'll refer to RHS as, right, I'll put it up here for reference. Int vector I equals J. In this case, I is left-hand side, J is right-hand side. Okay, and then also int vector I of J. Okay, so what do we got? We got two possibilities. Okay, remember the default constructor doesn't create an array. Okay, so we have to deal with the possibility that J has no array. That's one. But we also have to deal with the possibility if J does have an array. That's two, right? No right-hand side array. That's one. And yes, right-hand side array. Okay, so how can we tell? A couple ways, right? Since all objects are going to have a constructor that runs, if they don't have an array, that means it's the default constructor that ran. And if it was the default constructor that ran, that means its numbers is set to null pointer and its length is set to 0. Therefore, you can test either one of those. Okay, so what do we got? If right-hand side dot numbers is equal to null pointer, you can do that. Or you know, if right-hand side dot length is 0. Okay, either one, it would be the same, right? If that's the case, then in the left-hand side object in I, what we need to do is we need to set length equal to 0, and we also need to set its numbers equal to null pointer, right? Because we're initializing one with the other. Okay, they should look the same but different. Okay, so we got that, and I almost forgot to do this. What class does it belong to? Okay, there, done. All right. Otherwise, there is a right-hand side array. And so then, we'll set the length equal to the right-hand side's length. And then we will create a new array for this left-hand side object, for the I object. Equals new int length. Okay, once we've done that, now we can copy the contents of J's array into I's array. Okay, so for int I equals 0, I less than, I could use either length or the right-hand side object's length. I could either use this guy's length or this guy's length. Why? Because with this statement right here, I just made them both the same. I'll just go ahead and use length. Doesn't matter, you could do either one. Okay, so what I'm going to do, numbers of I, right? So I's array now is going to be assigned the value of J's array. Okay, and that should do it. Let's test it. Okay, let's test it. So let's go up to main. And we will create int vector uno, and then we'll create int vector dose initialized with uno, and then we'll check dose's length. Dose dot bullet size. Right. Should be 0. Let's make sure you can see the output there. Yep, there it is. Okay. Now, let's add to uno some values. We'll use its overloaded constructor. It'll be faster. How about it has 4 elements, each initialized to 2. Okay. Now, if this worked, then we should see 4 on there, and we do. Okay. Because in our copy constructor, this part right here is what executed. Okay. So let's also make sure that the values are in there. Okay. So for int I equals 0, I less than dose.size, I plus plus, cout dose.at I. Okay, and we'll put a space in there so we can see it. All right, and then we'll put a new line in. Okay, so let's see. All right, so 2, 2, 2, 2. And you know what? I don't want them all on different lines. Okay, so dose now contains its own array of 2, 2, 2, 2, 2. Okay. Now, let's make sure that the arrays are separate. Now, how am I going to do that? Because I'm going to change uno's first element. Okay. So I'm going to say uno.at of 0 is equal to 99. All right. So if I do that, then doses do that right here. Right. I'll do it after we initialize dose with uno. So that means that doses array should not have changed. So let's see it. Right, there's 2, 2, 2, 2, 2. But if instead I look at uno's, now we should see that 99 is the first element, right? Because they have 2 separate arrays. Okay, so copy constructor done. Right, now let's go look at the requirements and move to the next thing. The relational operators, equals, equals, and less than. These are easy. Matter of fact, once you write one of them, you could copy and paste it and just make one little edit and you're done. Okay, now some of you guys compared weird things. All I asked for was for you to compare the lengths of the arrays. Some people tried to compare the first element, right, of the arrays against each other. Some people one person tried to total up the values in both arrays and compare those. I didn't ask for that. You know, what did the requirement say, right? Let's go back and look at it. The requirement said, this will return true if the length of both of the arrays is the same. False otherwise. Returns true if the length of one is less than the other. Returns false otherwise. Okay? It didn't say to do anything else. So this one should have been really easy. Now, return type bool. Why? Because less than is true or false. Equals, equals is true or false. So I'll do the equals, equals first. Const int vector reference. I'll do this one in line. Okay, and it's a reference for the same reason. A const reference for the same reason that I talked about for the copy constructor. Now, the text, I don't think the text was explicit about this, but technically these guys are accessors. Okay, so since they're accessors, they should be labeled const. Why are they accessors? Because they don't change anything in the object. Okay, now these were worth so little that I felt really bad, you know, deducting half a point if you did put the const on there. So all I did was make a little note and saying, hey, technically these are accessors. Okay, so I didn't deduct any points if you didn't put that const on there for that reason. Okay, so what do we have to do? We just have to compare one length against the other. The left-hand side's length versus the right-hand side's length. Okay, and if they're the same, then we're just going to return true. Otherwise, oops, I want this stuff to line up. Otherwise, we're gonna return false. Okay, that's it. That's all you gotta do. Now, for less than, they basically do the same thing. All we gotta do is make one little edit. I guess two. That's it. Done. Right? So, let's see if they're both the same length. Right? So we can say if uno is equal to dos. Okay, see out. They have arrays that are the same length. Okay, so let's go ahead and run that. And you can see they do, right? Now, let's test it. Let's add to uno another value, right? So let's do something like, or dos, we'll add dos to another value. Dos.pushback 88, okay? And now we shouldn't see that line again, right? And we don't. Why? Because they don't have the same length anymore. Okay, now let's test less than. If uno less than dos. See out. Uno has a shorter array. And it does, right? Because we did that pushback thing up there. So now we're going to see that. Yep. Boom. Done. So that is the relational operators requirements. So let's look at the overloaded postfix operator. Increments every element in the object's array by one. Okay, so the big thing with this was that people they screwed up one key component, right? And again, I think this is because of what I was talking about before, how you just wanted to get done, and so you ran to the textbook, you skimmed over that section, you copied some code without really understanding what was going on. So let me go grab this section here for your reference. And there's a couple of things that needed to happen, okay, for this. One was that you needed to have that dummy parameter, yes, in the parentheses, okay, yes, you did have to have that. Right, but that's not it. That's not all of it. Okay, it's a postfix operator. Okay, if it was prefix, pretty much that a loop incrementing each element, and you're done, right? But that's prefix. This is postfix. So remember, with postfix operators, you retrieve the value and then you increment it. Okay, so plus plus, you retrieve and then increment. Okay, with prefix, it's increment then retrieve. So what that means is that we have to have this dummy object that preserves the original state. So that way we can return that, okay, that dummy. So that way it gets the logic right, okay? And some of you had that, but initialized it wrong, or you created the dummy object at the wrong place, stuff like that, because you didn't understand exactly what it was for, I guess. So let me go find the section number here, so that way I can tell you where to refer to. I'm looking in the text because I want to show you how closely it ties to the textbook, and everything that you need to do this is right here. It's here. There's nothing crazy, right? So Section 14.5, look for the heading overloading the postfix plus plus operator. And you'll see in the sample code there, I think it's for the feet inches class or whatever, there's a dummy object at the very beginning, right? Because that preserves the original state. And then there's a plus plus line, which does the incrementing, but you're returning the dummy object. And that's what allows for that postfix logic to happen. Okay, so let's add this in here. All right, so let's do it. So we're going to return a int vector. That's going to be our return type, because we have to return that dummy int vector. Okay, so int vector, and it's going to be operator plus plus, and then that dummy parameter. Okay, so let's go define this. Okay, so int vector. Okay, now this is easy because we can make that dummy because we've already set up the copy constructor for us, right? So here's what we do. Okay, we're going to do int vector. We'll call it temp because the textbook calls it temp too, and we're going to pass it ourselves. Okay, so this is that self-referencing parameter. We're dereferencing it, so we're passing to its copy constructor a copy of the host object. Okay, and so that's going to fire the copy constructor, set up everything, copy all the values over. So this is going to be a temp int vector that preserves state. Okay, so when you do something like this, right? Let's say that we had int vector I, and you said I plus plus. Okay, so this temporary object, before the plus plus happens, it saves the state of I. Okay, and then we return that. So that way it emulates that logic, that postfix logic. So we're going to return temp. Okay, and that has to be done first, because if you update the array first, which is what some people do, right? Then you're saving the updated array and just blew up the whole postfix operator logic. Okay, it has to come first. Okay, preserve I, then update I, but return the preserved I. Okay, so for int I equals 0, I less than, and by I mean this up here. Okay, I less than length, I plus plus. Okay. Now, this should be safe on an object that was constructed with the default constructor. Remember, there's no array in that case. Why? Because length will be 0. And so if length is 0, then nothing's going to happen, right? So numbers of I plus plus. Now here you could have done prefix or postfix. It wouldn't have mattered. Okay, you could do either one. Who cares? It doesn't matter. Okay, because that just adds 1 to. You could have done this too. Just adds 1 to the array. Okay, so that takes care of our postfix operator plus plus. Can I test it yet? No, I can't test it yet. We'll come back to this, right? We still need to test it. Test operator plus plus, right? Because what we'll do is once I overload the stream insertion operator, then we'll do it. Okay, and you'll see why here in a second. All right, so let's go back and take a look at the next requirement. The next requirement was overload the array operator. Okay, and the text. Let me scroll back over to Visual Studio. The text has you pass a constant int reference as the parameter, or has you use that as a parameter. You could have used int also. But yeah, this was really easy. The return type was an int reference. Why? Because it's an integer array. The operator, blah, blah. And the requirements, I said, allows updating of the appropriate element of the int vector objects array. Your method does not check if the argument passes a valid subscript or not. I was trying to make it easier, right? Some people did have some input validation in there of varying quality. Didn't have to do that because there was enough here to do already. Good idea to do that. You should normally do that. It would be something great to throw in there. But I left it out again just because there was enough work here. That's the only reason. So it wasn't wrong if you included it. It was totally fine. I think I might have scratched it out, struck through it with green or something. Remember, anytime you see anything that's green, that doesn't mean there's any points deducted or anything like that. It's kind of like FYI stuff. I think I just left a comment that said, like, you didn't have to do this. It's okay. But anyway, so parameter, you could have done pass by value. The textbook does const int reference. Constant reference, either one, don't matter, knock yourself out. I would argue that this is less efficient because you're passing a memory address then, which is 8 bytes, whereas if you're passing an integer by value, you're copying 4 bytes. Whatever, you could do whichever one you want. And all you had to do was return numbers of I. Right now, if you tried to access this, or if you tried to use that that operator with the default constructed object, you're going to be accessing an invalid memory location, right? Because it was initialized to null. But I let that go for the reasons I just explained. Okay. Now here's something else that's kind of interesting. Okay, and I didn't go back to Visual Studio, but here's the code that I was just talking about. Here's something else that's interesting. Technically, that guy is a accessor. Technically, okay. If you think about it, now I think that Visual Studio, is it freaking out on us on that? No, it wasn't. Okay, technically it's an accessor. Why? Because you're modifying the array, not the pointer, right? What are the actual attributes of the class? Length and numbers, right? The array isn't part of the object, right? The array is being pointed to by the object, but this thing doesn't change numbers and it doesn't change length. It doesn't change this pointer, doesn't change this integer. So technically, it's an accessor. Now that being said, that's too close to a trick question in my opinion, so I didn't dock anybody off for that. And it's, because when you think about this thing, normally you're thinking about it being, changing the object in some way. Now, if this array was statically allocated, then it would definitely be a mutator, right? Because you would be actually accessing and changing the array that's part of the object. But since we're using dynamic memory allocation, the array is not really part of the object. That's just an FYI thing, just for fun, just for funsies. Okay, so let's test it. So we'll change uno of 0 to 77. Okay, and then we'll see out uno 0. All right, let's take a look at the output for that. Make sure that it works. So there's the 77, right? So you can see that, right? Yeah. So that's done. So let's overload the stream insertion operator. That's next. So let me go back and show you the requirement for that. Yeah, it just allows an int vector object to be used with cout. Okay, and that was the first part. The second part was to format the output so it's in the square brackets with commas in between the numbers. So that's a little bit tougher than it seems. Most people did okay on it. The biggest defect that, or the biggest problem people had, what they screwed up on was either they didn't write to the OStream reference, they used cout within the function itself, or they didn't format the output correctly. They just maybe printed the numbers with a space in between them, or put them on separate lines or something like that. But most people got the majority of credit for it. All right, so let's do that. So some people defined it in line. That's fine if you did that, no problem. But I'm not going to do that. Okay, what's it take as arguments? An OStream reference and a const int vector object reference. Okay, so stream. Okay, this is the stream model of C++. You've got two things going into this function, and have to make it a friend because this operator is actually defined inside of that function. It's actually defined inside of OStream, and so what we're doing is we're overloading that function. Okay, anyway, so what's going into this function? The stream, that is the output stream. That's the stream, the type of stream that's used for writing to files or writing to the screen. Okay, so this supports stuff that looks like this: coutx, or if f is a file, right? Then something like this. Okay, so the stream is going into, implicitly, the output stream is going into that operator along with a reference to the object. Now what needs to come out is that stream that has had the data taken from the object inserted into it, right? And so then it comes out of the function, so that can be returned by it and sent off to either the file or the screen. Okay, so that's how that thing works. So let's define it. All right, so I'll name this O, and I'll name this RHS. Okay, so if we do something like this, right, then X is the right-hand side. Okay. All right. So now, remember we had to format it a certain way. So first thing we're going to do is we're going to put the left square brackets in the stream. Then we're going to have ourselves a loop that is going to go through the array, right? The array that is in X, or that's being referred to by X is probably a better way of putting it. So I can do it this way, and I++. Okay. Now, if the right-hand side object, if X was constructed with its default constructor, and it's got null, right? In other words, it doesn't have an array. What's the length going to be? 0. So what's this going to do? It's going to terminate immediately. And so we won't be accessing an invalid memory location, right? So it's kind of implicit in that. So what do we got to do? We got to take the array elements and put them in the stream. But we also have to put that comma in there, right? Then we got to put the closing bracket into the stream. Okay. And then we got to return that stream. Okay. Now let's test it. It's not quite done yet, but we're going to test it. There's still one thing more we got to do. So I'll just send uno to it. We'll see what it looks like. I'm trying to hurry so the video doesn't last for like hours and hours and hours. So hopefully I don't make any mistakes. But anyway, so there's the array. Now you notice how there's this little empty spot here at the very end. We can't have that. Okay. So what we're going to do is we're going to stop the loop one element short. Okay. And by doing that, okay, it doesn't quite get us there yet, but it will, okay? Because right here is where that last 2 should go. So what we'll do is we'll put it in afterwards. Numbers of, dot numbers of I. Now here's the problem. I is undefined in this scope, right? So we'll move I to here. And we'll just delete it from here. Okay, so now when this loop is done, I will have the correct index value in it. Okay, so let's try it again. And there you go, it's formatted nice and pretty. Now, the problem is what happens if it was constructed with the default constructor, right? Well, that's bad. Okay, so let's give you a example. Int vector trace, okay, and then cout trace. It's gonna crash, okay? You're gonna see here in just a second. You know why? Because in the case of trace, what are its attributes set to? Numbers is set to null, length is set to 0. So when we get here, right, what did we just access? We just accessed numbers of 0. There is no numbers of 0. That's why it crashed, right? So there was no problem here because of what I told you before, right? I is set to 0, rh.size is -1. Is 0 less than -1? No. So this never executes, but this still does. So what we're going to do is we're going to say, well, if the length of x, right, remember we're referring to this, that's the right-hand side object in our example. If that is greater than 0, then go ahead and do it. Okay. Otherwise, don't do anything. Now you see how we still got the opening and closing brackets, no crash, everything's fine. Okay. So that guy's done. And we're almost finished. Okay. So what's the last thing we got to do? The last thing that we got to do is that overloaded assignment operator, or that overloaded copy assignment operator. Copies the content of one int vector object to another. Okay, so a couple of things with that. Okay, we have to be able to support syntax that looks like this. Right? So that's going to require us to have a non-void return type. Now, some people used a void return type. Okay, that was one thing that was wrong. Another thing we have to do is we have to deal with self-assignment. Syntactically, it's stupid, but it's a possible thing to do, right? So if you're just going to assign yourself to yourself, there's no work to do. You're yourself. So we want to make sure that operator equals, that assignment operator doesn't do anything in that case. Okay. We also have to deal with if right-hand side has an array and right-hand side has no array. Okay, similar to the copy constructor. Right. So let me go back to the text and refer you to the appropriate section where everything you need is at. The thinking isn't, right? But the explanation of how things work or how the operators work or how they're overloaded is there, right? It's up to you to figure out how to apply the tool. I show you how to use them. It's up to you to apply it, okay? The thinking part is the hard part. So operator overloading was section 14.5, and the equals operator, the assignment operator, the copy assignment operator was the first main subsection, overloading the equals operator. Now, if you just skimmed through that and got to the very first part that has the first prototype for it, you didn't go far enough, right? It says return type void. That is wrong. Parameter list is correct, function name is correct, but the return type is wrong because if you scroll down, you'll notice that it immediately starts talking about the return value. There's a whole subsection that says the equal operator's return value, and it talks about this this assignment, this weird type of assignment, right? A equals B equals C. Okay, if it's multiple assignment. So if you didn't go that far, if you just tried to rush through everything, you missed that. So that happened a couple times. Okay, so what do we need? What do we need to do? Okay, well, what we're going to do is we're going to have a const int vector return type. Okay, and we're going to have operator equals, and then our right hand side is going to be a reference for the same reasons that we talked about before. Okay, So there's our prototype for it. Let's go define it. And then we'll test it. We'll also test the postfix plus. Okay, so we'll name this RHS, and I have to put the class that it belongs to in here. Okay, boom. So the only time we want to do something, okay, is if we're not doing self-assignment. Okay, and that is the test for it. Now, we're always going to return a copy of ourselves, right? So, for reference here, when we say x equals y, okay, x is this, it's also the left-hand side, and y is the right-hand side. Now remember, x equals y is the same thing as this. These are just functions, they're just methods. Okay, so what's the left-hand side? X. What's the right-hand side? Y. Y is being passed by reference to that parameter. Okay, so if we're doing this, if we're doing x equals x, it's pointless. There's nothing to do. Okay, that's why we're checking for self-assignment. Okay, but we still have a non-void return type, so we're always going to return a copy of ourselves. Okay, so no right-hand side array and yes right-hand side array. Okay, now how are we gonna check? Similar to what we did with the copy constructor. So if right-hand side dot numbers is equal to null pointer, then there's nothing to do. There's no copying, I should say, that's going to happen, right? All we have to do is set our numbers to null pointer and length to 0. Boom, done. Otherwise, there's an array to copy. Okay. Now, this gets a little bit more complicated, right? Because left-hand side, in other words, x might already have an existing array. Okay. If it does, we got to delete it and create a new one. Okay, and then copy the contents of right-hand side's array to the left-hand side's array. Okay, but we're going to check first. If numbers is equal to null, or is not equal to null pointer. Okay, if that's the case, then that means that left-hand side has an array that we have to delete. We could also have tested length. So delete numbers. Okay? This is all about logic. There's no code in here that we haven't covered. You got to think, and the thinking is the hardest part. Okay? It takes the most time. Right? Anyway, otherwise, let's go ahead. I mean, not even otherwise, but now we're free to go ahead and create the new array no matter what. Now, we need to know what the length is of right-hand side array, so we're going to grab it. Okay, now we're going to create an array for left-hand side using that length. Now we can do our copy. I less than length. I could use length or right-hand side length, doesn't matter because they both contain the same value. Okay, and then I'm going to assign to left-hand side's array the contents of right-hand side's array. Okay, so whose right-hand side? In our example up here, that was y. Whose left-hand side? In our example up here, it was x. And that should do it. Okay, so let's go test this. Okay, so we'll assign to tres, we will assign it uno. Okay, now let's go ahead and see out tres and uno, and they should be the same. And they are, surprise, surprise. Okay, so that looks awesome. Now, I mean, one other thing I could test too would be if I tried to assign a int vector object that has no array to trace. Okay, that should make sure that there's no crash, right, and that I don't display anything. Okay, so trace equals quattro. So let's do trace and quattro. There should be no crash, right? Because in this case, quattro has no array. So we detected that right there. Okay, so let's check it out. Did I push compile? There we go. So see, they're both empty. They're both empty. Okay. Now you're thinking, how could I figure that out? You could have figured it out. Okay. You could have figured it out because you have to understand how things are working. You have to understand how the pointers are working. You have to understand how the original class was built. The fact that that default constructor uses null. Okay. And how's that going to impact everything else? Okay. There's no code here that you haven't seen. None of it. Okay. But it's tricky because there's all these little details. You have to think through every single little thing. And, you know, a way that you can do that is to draw pictures, to use your pseudocode, to hand trace, to use flowcharts. Okay, so let me give you an example. Okay, and then we'll test that numbers plus plus, and then we're out of here. Okay, and this was a hard one. I told you it was going to get hard towards the end, right? There was only a few people who got 20s on it, but the good news is that you know, there's still points to earn, and most people are still doing completely well. Okay, might be a little bit of a wake up call for you. Okay, and don't forget, lowest scores dropped. So if you did poorly on this one, did awesome on everything else, well, this isn't going to hurt you at all. So I just want to encourage you. I'm encouraging there. No, I'm not going to give you extra credit, right? Because I dropped the lowest score, and also you can work with a partner. So you know you don't deserve any extra credit. And the tests aren't worth hardly anything, right? They're take-home tests. Anyway, where was I? Yeah, I was going to show you what I mean. Let's see here. Let me go to my whiteboard. Okay, so here is my whiteboard. Can you see that? Yeah, you can. Okay, what's the default constructor do? Right? The default constructor creates an object that contains a length variable and a numbers pointer, right? And this is when you do something like this, int vector uno, right? When you do that, what does that constructor do? Look at the code. Well, you know, while you're looking at this, it initializes length to 0 and the numbers pointer to null. Okay, so right now, if you try to do uno 4 equals 3, what's going to happen? There's no array here, right? It's easy to tell what's going to happen, right? You're going to be accessing an invalid memory location. So what do you have to do? Well, you could call pushback, right? Remember how pushback worked? Pushback created a new one element sized array, put a value in there, right? And then incremented length. So now if you were to say uno of 0 equals 2, right? Well then, no problem, okay? So, you know, you can think about that. And you can also think about, okay, well, if I have uno, right? You think, right? I know it's hard, and I'm not picking on anybody, and I'm not trying to, you know, I'm trying to encourage you. That's what I'm trying to do, right? And I'm trying to break you of that habit of just going in there and writing code without really thinking about what's going on, right? But anyway, so if I do uno equals dos, right, what's happening? Remember, the uno object has got its length variable set to 0 and its numbers pointer pointing to nothing, right? So what does dos have? Well, it was originally initialized the same way, right? So now when I set uno equals dos, well, they need to look the same way. Now let us say, when you're done, now let us say that we had something like this, okay? So let us say that uno was initialized with 3 elements that were initialized to 1, and dos was initialized with nothing, right? Well, uno now has an array of 3 elements that all have 1 in them, right? So that's going to dictate to you how you need to write your assignment operator or copy constructor, right? You can't just set, this would actually say 3, wouldn't it? You can't just set numbers to, in dos to numbers of uno, because you'd end up with both objects pointing to the same array. You can't do that, right? Instead, what do you have to do? Exactly what we did in the video that I showed you, right? First, check to see if dos was pointing at anything. If it was, delete it. Well, it's not, right? Check for self-assignment. I mean, I guess that's the very, very first thing. Okay, but if it's not pointing at anything, don't delete anything, but then create a new array that it points to, right? Set its length to 3, and then do your copy. It's all about the steps, man. It's all about the steps and coming up with the algorithms. That is the most important part, not the code, okay? Now, if all you've been doing is trying to figure out, or previous to this chapter, or maybe the most recent chapters, if you're trying to do it all in your head, you got to stop that. You got to stop it. You're not going to be able to be successful if you try to do it in your head. It gets too complicated too fast, right? But if you think it through, and you think about the different scenarios and possibilities, and well, what does it mean? The default constructors, make some little notes, study that original class. Default constructor doesn't create an array. Right? So you got to take that into consideration with everything else that you do, right? We're comparing lengths of arrays, right? For the relational operators, comparing lengths, right? We have to deal with self-assignment. We have to deal with multiple assignment. We have to deal with, right? You think about all these different pieces. Okay, and then that dictates how you write your code. What are the requirements? And the requirements, kind of spell it out. And the textbook talks to you about what you need to have, right? So you got to think that through and have a good idea of what it is that you're trying to do before you start writing the code. Every single piece of code that I wrote, let's go back and look at it, in here, was for a reason. It was dictated starting from the requirements and then taking into consideration some of the practical limitations that I had. The default constructor does one thing, the copy constructor or the overloaded constructor does something else. Okay, and I built it that way in the original assignment to try to force you to think about these things. Okay, but anyway, so that's everything that I have for you. By the time you watch this video, the solution will be replaced with this code, so that way you can follow along, have that solution for you, and you can be following along the video if you want, or you can be writing the code as, maybe you don't want to look at the solution. Maybe you just want to look at, create the code as you go along, whichever. If you have any questions about any of this, if you anything, right? I mean, and if some of the feedback that I didn't leave on your assignment, if the feedback I left on your assignment didn't make a whole lot of sense to you, email me. Email me and I'll send you a quick clarification. Do that first because my office hours are only half hour long, right? And so, I really only have time to help 1, 2, 3 at the max people with quick questions. So, give me a holler, okay? Give me an email, and then stop by if I can't answer your question that way, okay? All right. So hopefully that was helpful and gave you some things to think about and cleared stuff up for you. All right. And yeah, I mean that's a tough chapter, man. Not gonna lie. It's tough just because of all those little things, and all students, struggle with it because there's just so much there, and the fact that it's the first really challenging maybe chapter that you have because of all these things. But what I said at the very beginning, I think in the intro video, is true. It's absolutely true. They're just functions, right? They're just methods. If you can write a class, then you can overload the operators. But you have to be paying attention to all of these things, and you have to understand why you write the code that goes into those operators. And if you don't read the text, if you don't watch the videos, if all you do is just go and grab the sample code and then try to manipulate it in a certain way to get it to work, you're never going to figure it out. You got to stop that right now. If you want to really learn how this works and how to master it, and I've talked to some of you guys in office hours and why I do the things the way that I do, because, and why I don't pre-grade stuff. And when you send me an email or you say, can you look at my code really quick? And I've talked to some of you guys why I don't do that. Because you need to show me that you know what you're doing. You need to build the confidence up to know your confidence up to know that, yeah, this code goes here because it serves this purpose. Well, how do you know which code to write? How do you know what purpose it's serving? Understand the requirements, come up with a plan, and then write the code to implement the plan. If you're skipping right to step 3 in writing code, you're doing it backwards. You're absolutely positively doing it wrong. And that works up to a certain level, and I'm not picking on anybody. I'm trying to help you, right? Because everybody does that. They want to write code, and they don't want to think. They don't want to stop and think first and really understand what they're doing. It's one of the reasons why, and really study the requirements. It's another one of the reasons why I have that stupid little point for naming your files correctly, right? Because I want you to read and scan it and get it right. And I'm trying to emphasize that requirements are king, and I'm trying to give you a free point too, right? All you have to do is read the requirements. But yeah, you really gotta buckle down. Now the good news is that, again, everyone's doing great in the class. You guys are doing fantastic, really. I just wanted to help you out with this video and do this solution for you because everybody, almost all my classes, both universities, you're doing fine. Then you hit this chapter and you're just like, boom! It's like smashing your nose into a wall. If you are struggling with it, don't panic. You're gonna see this material again, and in the remaining assignments in our class, you're not gonna have to worry about. You're gonna write a class that implements a linked list, and it's not, you're not going to have a whole bunch of overloaded operators and stuff like that, just because dealing with the linked list itself is going to be hard enough. And then you're going to have a chapter on recursion, right? So this was probably the hardest chapter of the entire class, I would guess, right? So you're doing fine, and you're going to see it again in your object-oriented programming class. Okay. All right, that's everything I got for you. Let me know if you need anything. We'll talk to you there.